Hello everyone and welcome to session 7, the penultimate session of Warwick Data Science Society's Beginner's Python course. So we have no recap notes for the start of this, but as always if you're watching one of our hybrid live sessions, now's your chance to pop any questions in the chat and we'll get to them before we start the session. So the content for today is learning about this new data type called a dictionary. This will help us to overcome some of the limits we saw with lists and tuples. And so we're going to learn how we can create these, how we can manipulate them, and then how we can loop through those. So we'll just pause now for a second. If there's any questions in the live session, we'll get started on today's material. Okay, so we're going to start by having a discussion about the limitations of lists and tuples to try and motivate ourselves as to why we need these things called dictionaries. And so we've seen lists and tuples a fair bit. They're a very flexible data type. They're very good for when we have multiple bits of data, we want to store them under one name. So rather than having 10 different variables for 10 different things, we would combine those together into a single variable that is easier to access and easier to manipulate. And so, that said, there are limitations of lists and tuples. And typically, they're a great way of storing data that has a well-defined order. So we can order those using non-negative integers as the indexes or addresses of the data. So an example of when this would work well was if we wanted to list various capital cities by their populations in decreasing order. So, for example, we could have Beijing having the largest population, New Delhi, Tokyo, down to Moscow, and we could index these as 0, 1, 2, 3, where the index is going to tell you whether you're the biggest, second biggest, third biggest, etc. So there's a natural order to this data. And another case when a list or tuple works well is when we just don't care about the order at all. If we just wanted to have a list of various cities in no particular order, a list would also work for that. But sometimes there's some more structure to our data. For example, what we have on the right here is we want to store data of the capital city of various countries. So we want to know that if I want to have France as my kind of index, then the answer should be Paris. If Germany is my index, then Berlin should be the value associated with that. And so here we kind of have more general indices. Here the indices were non-negative integers, but in this case, the indices themselves can be bits of data. And so if we were to try and represent this as a list, we would need some way of ordering all countries. And that would be very unintuitive. Like, we could think up an order of the countries, perhaps alphabetically, but that wouldn't be intuitive. It would be much easier just to say, hey, I want to have the data associated with Spain, and the answer comes back as Madrid. And so we need a whole new paradigm to tackle this sort of data. And it's called a dictionary. And it's very similar to a list or a tuple, but rather than indexing by non-negative integers, we index by whatever we want. And we change the terminology from an index to a key. Because you can think of a key as something that opens a door, so it kind of opens a door to whatever value you want. Or you can maybe think of it as a key on a map that tells you how certain symbols map to certain real-world objects. And so we created a dictionary in Python using curly brackets. So we saw square brackets for a list, parentheses for a tuple, and finally curly brackets for a dictionary. And then we separate multiple items in this dictionary using commas. And so an item is kind of a special kind of term for referring to the elements of a dictionary. And those consist of these things called key value pairs. And so we can see back here that a dictionary is made up of kind of these keys that map to a certain value. So the key France should map to, given the information of Paris. And so we represent these key value pairs. Each key value pair is called an item by writing the two values separated by a colon. And so the keys are the things that are on the left, and those are typically strings, integers, or floats. Those are kind of an address for some data, kind of the name of that data. And then on the right, we have the value, and that's the actual data we're associating to that key. And so that we can then access dictionaries in a very similar way as we would with a list, using square brackets. But rather than using a non-negative integer, we use whatever the value of the key is, which could be a non-negative integer, but it could be a lot more data types. And so, for example, we can create a dictionary called house here. So we use curly brackets, and I put this on multiple lines, which you'll be used to by now putting new lines in Python, we're free to do that. It doesn't change how Python understands things. It's just there to avoid us having really long lines of code. So a dictionary called house, and there's 2 commas here. So there's 3 different items here. So the first item is a key value pair separated by a colon. The key num bedrooms maps to the value 3. So in other words, the number of bedrooms we have is 3. The type maps to the colon here, the value semi-detached. And extra rooms here, the corresponding value for that is a list. So we're capable of storing dictionaries and lists and tuples and whatever value we want as the values of our dictionary. So there's a lot of flexibility there. So here the extra rooms is a list called kitchen, lounge. And we can access a certain value by using square brackets, and then we put in whatever key. And the important thing here is that the key is a string, so we have to use quotes here when accessing it. If the key had been a number, say it'd been 3:3, then we could have just put a number 3 in here, and that would have been the corresponding key. But for dictionaries, it's fairly typical to use strings for keys. That's why we're using dictionaries, to have that more flexibility of types, so we want to take advantage of that. Okay, and so I'm just going to go off on a quick tangent about the ordering of dictionaries. And so Python does not keep track of the order of keys in a standard dictionary. Actually, this has changed a bit over the evolution of the language. It kind of semi-keeps things in order, but it's best assuming that it doesn't, because the behavior can be quite complicated and inconsistent across versions. And so, for that reason, the best thing you can do is assume that whatever order you put things in your dictionary, they'll be randomly shuffled around after, so you can't rely on their order. And so, if you need to keep track of the order of things in a Python dictionary, then you can use what's called an ordered dictionary. But it's rarely the case you want to do this. If you have a dictionary that has an order to it, well, then you probably want to be using a list. Like, lists are used for ordered data. But if you want to use an ordered dictionary, have a search for that. You can see how you do it. But here is an example of the order being inconsistent. We have word lengths here, and we have zebra mapping to 5, armadillo to 9, kangaroo to 8. We then go to print out word lengths, and we see that things have now been reordered in alphabetical order. I think generally that's the rule in modern versions of Python, but you can't rely on it too heavily, so it's worth not even trusting that and assuming they're completely random. Okay, so what happens if we try to access a value that doesn't exist? Sorry, a key that doesn't exist? Well, then we get an error, what's called a key error. So if we look back at our house dictionary, there are 3 keys here with corresponding values, and has basement is not one of them. And so we get a key error for that. And how can we get around this to make sure our code doesn't run into errors? Well, we can use the in keyword. And this asks if a certain kind of value is in the set of keys for a dictionary. And so we have here, if num_bathrooms is in house, so is num_bathrooms in the set of keys, then we go and print out whatever that value is. Otherwise, we print out, well, there's probably at least 1. And so this is how we can handle those special cases where we might not know whether a certain key is in the dictionary, whether there's a corresponding value. And we'll see in the additional notes, if you have a look at those, a more elegant way of doing this, where you can, in one line, access a value. If it doesn't exist, if there's no corresponding key, well, then it returns a default. Have a look at those notes for that if you're interested. So with that, we're going to have a go at these puzzles, trying to learn a bit more about how dictionaries operate, and then we'll join back again in a moment to look at the solutions to these. Okay, let's have a look at these solutions then. So the first 2 exercises are fairly straightforward. Just creating a dictionary here. So I'm Tim, I'm 22 now, a male, and the languages I use, here's a list here, Python, R, and Julia. So as I mentioned before, we can put a list as one of the values, we could put a dictionary, we could put a tuple, we could put dictionaries inside dictionaries inside of dictionaries. It all goes the whole way down. So it's a really flexible data structure. Then printing out a few values, we just use these square brackets and the corresponding key. So take my details and then use name. So I'm Tim and I'm 22 now. And so the more interesting question was, what happens if we have something like this? And Here we have a repeated key, x is 1, then also x is 3. What's going to happen, perhaps unsurprisingly, but it's good to know, it takes the last value that we set. So x is going to have the value of 3 here. This first one is forgotten. And this comes from some kind of underlying behavior of how dictionaries relate to these things called sets, which we'll learn about in the additional notes. It's also very convenient for when we're merging two dictionaries together. That's just something to bear in mind for those kind of odd cases. Okay, so how can we manipulate dictionaries? We saw when we introduced lists, 4 different ways we could either delete, overwrite, or add elements to a list. Let's see how we can do that with a dictionary. And so a lot of the methods are fairly similar. And we're going to use this example dictionary here called Scrabble, and it's the values of 3 different Scrabble tiles, A, C, and F, are 1, 3, and 4. So we can add a new item by using the dictionary followed by square brackets. So we're accessing something that doesn't exist, and we set it equal to a certain value. So here we're saying take the key Q of Scrabble and associate it with the value of 10. And so by doing this, we get a dictionary with these 3 values, and then Q is mapped to 10 there. And so again, adding this thing could change the order of things. Don't rely on that. It's really bad practice. And so we could also overwrite a value if one exists already. We just do the exact same as before, but we use a key that already exists. So Scrabble of F is equal to 2. This turns out to be from the Anglo-Saxon version of Scrabble. Didn't know that existed, but it does. And in that game, F has a value of 2. And so we overwrite that with a value of 2 here. We can delete an item by its key. So we know the key we want to delete. We simply access that key and prefix it by the del keyword, which means delete. Now we'll delete it, and we'll see Scrabble now has only A and F. Now we saw with lists how to delete an item by its value. With dictionaries, that's a bit tough. We'll have a look in the homework at how you can do that using a loop. But we'll need to get onto that first. So with that, let's have a go at these puzzles here. We'll join back again in a moment to look through the answers. Okay, let's have a look at the solutions to those. So the first one was creating a dictionary with a mistake in it. That is, numbers has the word 1 mapping to the number 1, 2 to 2, and 3 to 4. And so we want to replace this 3 with the correct value. So we just simply take that key, it already exists, so we're going to be overwriting it, and set that equal to the value of 3. We can add a new value with the key 4 using this notation here. And so the next thing concerned making a dictionary using a loop. And so we start by creating an empty dictionary. This is something we haven't explicitly mentioned so far. But we can do it by simply having 2 curly brackets with no items inside, in the same way we would create an empty list with just square brackets. We can loop through the values of n in the range -5 to 6, so -5 to 5, we don't include the last one, and then set the square of n equal to n squared. And so I'm going to pause for a moment now to discuss, actually, is this an appropriate way of using a dictionary? Because this one's right on the border here. It's because, we're not indexing these n's here. They go from -5 to 5. So we're not doing the standard 0 to whatever that we would for a list. But it will be possible to offset these so that 0 corresponding to -5, 1 to -4, and carrying on like that. If we knew that our values were going to be -5 going upwards, then a list might be a more appropriate type. We just have to include an offset to get things down to -5. Now, where it would really matter that we use a dictionary is if we were doing all these squarings, but sparsely. So here we have the squares -5 all the way up to 5, and we have every single one. But imagine if instead we had the squares somewhere between -1,000 and 1,000, and had some kind of randomly numbered ones. We had -1,000 squared, we had -990 squared, -987, just random numbers between those. If we were to try and store that in a list, well, then we'd need to have every single one between those, and just have them either being a missing value, or maybe we have some symbol we use meaning that this hasn't been given a value yet. That's very inefficient. We're storing that whole list for those whole 2001 keys, when actually we only want a few sparsely populated ones. And in that case, a dictionary is so much better, because a dictionary, we get to choose the exact keys we want, and so we can skip out certain values. Whereas a list is very good when we have sequential every single value. But that's just something to bear in mind, when choosing between those two. If we're dealing with sparse cases where we don't have all values, a dictionary is much more efficient and conceptually much easier to use. Okay, so how can we loop through a dictionary? Okay, there's actually 3 ways of looping through a dictionary, depending on what information we care about. So here is a dictionary of ages. Anne is 20 and Bob is 23. And we're going to loop through those in 3 different ways. So the first way is looping through the keys of the dictionary. So just getting the things on the left of each item and ignoring what the values are. And to do that, we do for whatever our looping variable is. This could be any value. Typically, we choose something that makes sense for the context in the dictionary .keys. And this .keys method, a method is kind of a function belonging to an object, we'll kind of extract those keys out in an iterable way, so we can loop through those. So we have each name. We call this name because the ages, the keys represent they represent names. And so we loop through those, and then each name is going to take the value of Anne, then Bob, and if there were more, it would take those values too. And you can print that out each time. We then loop through the values, so we did .keys for the keys, .values, brackets for the values, and those are going to be 20 and 23. And here we use the looping variable of age, because those values represent ages. Finally, what if we want to loop through both at the same time? Well, then we can use ages.items. Remember, the items are those key value pairs. And we simply use a comma here to kind of expand those 2 returned values, one into name and one into age. And then for each loop, we'll look at the item, and name will take the value of the key, and age will take the value of the value. And so we can print out name is age, and we'll get these sentences here. So which one should you use? Well, you want the most minimal one for your use case. If you're only using the keys or only using the values, well then use the corresponding ones of these. Don't add added complexity to your code. If you do need both of them, then use items. But the key idea is being minimal. If you don't need to use the age or the name, well then use one of these more reduced forms. It's more clear what you're doing to someone stumbling across your code for the first time. Okay, oh yeah, so those are the three methods. Okay, so let's have a look at this puzzle here. It's a bit tougher than most puzzles. Try and wrap up this session. It's quite lengthy, so have a go at it. If you can't come up with the solution, no problem. We'll look at that in a moment. You can always come back at a later point to try and revise or practice this. So join back again in a moment. Okay, so hopefully you've had a good try at that. Again, if you didn't quite get it, not a problem. We're going to look at the solution now. So we're creating a function, like we did in the last session, that takes in a list of strings and counts how many times each string occurs in that list, and prints it out like this. So there are 12 occurrences of, say, the word spam. So there's a few hints here, but let's walk through it bit by bit. So a lot of code here. We can actually make this a lot shorter if we're using some of the techniques from the additional notes, but this is kind of using the techniques we've seen so far. So we create a function called countStrings, and it accepts a list called string_list. And so we're going to create an empty dictionary to keep track of the counts. I should also mention before we start, this here is a design pattern. So we've seen a few design patterns before. We saw one called the reduction design pattern, and I forget the other one that we saw. But design patterns are kind of common templates of code we can use for certain tasks. And this sort of template of looping through a list and building up a dictionary is really common. You can use it for a lot of problems like this here. So what we're going to do, we're then going to loop through each string in this string list. We're going to use S, keep it nice and short for each string as we go through. And so now what we want to do, we want to take these counts. If that string is already in our dictionary of counts, well, then we just add 1 to the count. There's 1 extra. And if it's not there, well, then we have to set it to its initial value of 1, the first time we've seen it. So if S is in counts, if we have that key there, we can simply take whatever the value of counts at that string is and add 1 to it. So we could have wrote counts s equals counts s plus 1, but here we use the plus equals kind of a shorthand notation for that. Otherwise, we haven't seen that string before, and so the count for that string should be given the initial value of 1. So that's going to build a bit of a dictionary of counts, and it's going to look something like a certain word, colon, maybe 3 if we saw it 3 times, and if we never saw the word, it's not going to appear in that dictionary. We can then print out the counts by looping through both the string and the count in the items, both at the same time, and we can say there are C is going to be the number of counts, occurrences of S is the string. And we can run this on the list of strings hello world and hello, and then we get this output here. And notice I didn't put in the special grammar here, so it should be there is 1 occurrence. But you can do that. I think if you look at these solutions online, there's the full way of doing that with correct grammar. So actually, we're going to spend a bit more time now looking at an application, because this course so far has been very teaching heavy. We've been learning how do you do this, how do you do that, but not really applying it to anything. And so we're now quite a far way in, and so I want to take a moment to actually look at, well, how can we use this stuff to actually make some sort of program, make a small piece of software, a little tool. And what we're going to do, we're going to use a thing called the Google Books API to collect information about various books, such as their author, how many pages they have, based on their ISBN code, which is a unique identifying code for all books. So we'll jump back in again in a second inside of Google Colab to have a look at how we would do this. Okay, so for the next few minutes, we're going to break down this notebook here, which you can find on the course website. It's going to show us how we can use Python to extract information about various books based on their ISBN, this unique identifying code for all books. And we're going to do this using a thing called the Google Books API. So let's start by explaining what an API is. I'm going to give a very brief definition. If you want to learn more about it, I'm going to link a blog post that What Data Science Society wrote on their research blog, which talks a bit about what an API is in a conceptual way. But the general idea is it's a way of communicating with a service or database. And so we're going to use the Google Books API to communicate with the database Google runs about books, kind of data on various different books. Some APIs are free, some are free once you've signed in, and some are paid. So Bloomberg, for example, has an API on financial data you pay a lot of money for. And so the Google Books one is free and doesn't require any sign-in or authentication, which is great for getting started, although most APIs do require you to log in. Actually, if you want to see an example of using an API for Spotify to kind of get information about different songs, we ran a workshop on that, which again, I'll link in the description for this video. So let's have a look at how we can use the Google Books API outside of Python. So all an API is a special web page we go to. So here the web page is googleapis.com/books, version 1 of the API. Volumes is known as kind of the endpoint of this, the information we're after. And then we have $Q, and that refers to our query. And our query is, I want the ISBN of 97 whatever. And this is the ISBN code for the book I'm interested in. I go to this website, and I get this response here. Actually, it would look something like this. I have a special plugin in my Chrome browser that makes it a bit prettier. You can have a search for that in the Chrome store. So we have this here. This is called a JSON file. And JSON is a really popular data structure on the web for storing kind of nested, complex data. Or fairly unstructured data. And so I'm just going to parse this, make it a bit prettier. And we can see here that we have a lot of information about the book with its ISBN code. So it was Python Data Science Handbook by Jake Vanderblas, and it's in the computer category. It's got an average rating of 5. It's a great book, and definitely have a look at that if you're interested. And various other bits of information, such as the description of it, say, and other identifiers of it. Okay, so this looks an awful lot like a dictionary. So we have these curly brackets here. These square brackets look a lot like lists. Then we have these key value pairs. And basically JSON is really similar to Python dictionaries and lists combined together. And so we can import this into Python really easily. But to do that, we're going to need a few extra functions that aren't included in Python by default. And to do that, we have to import these functions. And we'll learn how we can do that more and get the nuances of this process in the next session. But for now, I'm just going to show you the code for that. And that's these two lines at the top here. Let me just connect. So we have this allocated computational cluster. And we're going to import these two functions, URL open and load. So what URL open does is it allows Python to open a URL. So here we visited the URL manually by typing it in. If we want to do that inside of Python, we need a function to do that, and that is URL open. And what we get returned is a JSON file, and then the JSON module has a function called load, which lets us load in a JSON file into a Python dictionary. So we're going to import those two just using the code at the top here. Just got to verify that, and we're all good. Okay, so this here is the full code. But what we're going to do instead is we're going to break down exactly how we would do that bit by bit. Okay, so yeah, so the full code is above here. And I guess, yeah, let's see what the output is first. So we create this function here. We run this, and it loops through these various ISBNs and prints out the book name and who it was written by. So here we have the canonical data science books in Python, R, and Julia. So we're not going to get into how this code works. You can look through it for yourself. We're going to have a look at how we can do a very simple example, which was kind of basically all you need to know to build this whole thing at the top here. So we're starting with an API link, and it looks something like this. So we have whatever the kind of endpoint is, followed by our query, and we would just replace this with whatever ISBN we wanted to search for. And the return value is a JSON file. So what we can do, we can put this URL into URL open. That's going to open that URL and return a response. That response is a JSON file. We can then use the load function from the JSON module to load that JSON file into a Python dictionary. And then we store that in all_info. So we run this. That makes the query. Let's have a look at all info. It's a massive dictionary with all of this information here. Okay, so we can now start to kind of figure out where the information we care about is. And we can do this by some experimentation. So we have this all_info. Let's have a look at what keys we have available. So .keys, run this, and we see we have kind, total items, and items. So that's a bit confusing. Let's maybe have a look at some of those to see what those actually contain. So kind, what's that? Volumes. Okay, I guess that makes sense. We were querying the volumes endpoint, and so this is just saying that the type of object we got returned was a volume. We then have total items, and this is 1. So I guess this is suggesting that certain books are stored in more than one volume. If I had an encyclopedia, say, that could be in numerous different volumes. And so this is just saying we have a single volume here, but the structure of that API is flexible enough to have books in more than one volume. So in that case, I probably just want to take out whatever the items are. So we have items here. That was another one of those. We see this is a list because it starts with a square bracket. I can assume that the length of this is going to be 1 because this is a list of all the different volumes in that kind of book series. And because we know there's only one of those, this should have a length of 1. Great, okay. So I can now extract out that first one using the index of 0, because this is a list with a single thing. The first index is a 0. Great, so now we have the actual book we care about, which was the only volume of that kind of whole collection, I guess. Let's have a look at the keys of this. Okay, so we now have kind, ID, e-tag. Okay, volume info. That looks like the stuff we're after here. So information about this volume. So let's put this in here. We get another dictionary, just dictionaries inside of dictionaries. What keys do we have for this one? So title, subtitle, authors. Okay, we're looking good here. So we can now say, I guess now we're down to this bit here. So we have all info items 0 volume info. So we're going to save this to book info. Book info contains all the information we care about this book. And you can see here it has keys of title, subtitle, a list of authors, who published it, and various things like that. This is the stuff we care about the most. And so from that, we can have a look at the keys for this. So the keys are title, subtitle, more of those. And finally, we can print out different bits of information about that. So we could use the authors key to pick out who the authors are. We see here that this was a list of authors. The number of pages is in page count. We can see that over here. That was 529. And then a final thing, we take the average rating, round that to the nearest integer, and then we do a bit of clever string manipulation using these stars to print out how many stars the book had. So that's how we manipulate it. And then all we do in this top bit is turn this into a function. So now we put in an ISBN, add that on to the end of query, then run the same sort of code again, returning the title and the author to be printed out like this. So that's an example of how we can use Python. And it's quite an exciting example. We've been learning Python for only 7 sessions now, and we've already made, this could be a product. If you ship this in the right way, perhaps added a web interface to it, you've made a very useful tool here. Give me your ISBN, I'll give you the rating. There are certainly products that could be made based on that. So really exciting to see what we can do with only 7 weeks, and makes you wonder, learning a bit more, what you could possibly get to. So with that, we'll end today's session. Thank you for coming, and I'll see you next week in the final session of this course.